Hello everyone. Welcome to my YouTube channel on engineering mathematics. In my previous video, we saw definition of gamma functions and some of its properties. Link of that video is given in the description box. This video is the continuation of my previous video. In this video, particularly we will focus on evaluation of single integrals with the help of gamma functions. So let us see examples on it. Before that, let us recall a definition of gamma functions. For any real number n greater than 0, gamma of n is defined as integral of e raised to minus x into x raised to n minus 1 dx over the limit 0 to infinity. I hope you remember this definition. Now using this definition, we will solve some of the integrals. Let us see those examples. In example number 1, we are asked to evaluate integral of e raised to minus x cube dx over the limit 0 to infinity. First of all, we label this integral as I, then we compare it with the integral that we saw in the definition of gamma of n, that is integral of e raised to minus x into x raised to n minus 1 dx over the limit 0 to infinity. After comparison, you may get a clue to decide the substitution with the help of which you can transform this integral I into this form. Look at here, limits of these integrals are same. Here an exponential term has power minus x, but here the exponential term has power minus x cube. So we will transform this by using substitution. X cube is equal to t. After this, we will write what is x out of this. So here x is t raised to 1 by 3. Then you can use this statement to find out value of dx. So dx here can be obtained by differentiating this equation. Dx will be equal to 1 by 3 into t raised to minus 2 by 3 dt. After this, we will find out limits for t if limits for x are 0 and infinity. For that, we substitute these limits of x one by one in this statement and we'll find out the corresponding value of t. So after substituting x is equal to 0 here, we see t is also 0. Similarly, after substituting x is equal to infinity here, we see t is also infinity. Now we are all set to transform this integral from variable x to variable t. Look at here. After transformation, I will look like integral from 0 to infinity. E raised to minus x cube will become e raised to minus t, and dx we have already found in terms of t as 1 by 3 into t raised to minus 2 by 3 dt. From this integrand, I see 1 by 3 is the only constant term that we can take it out. So inside the integral, we will have e raised to minus t into t raised to minus 2 by 3 dt. Now we compare this integral with the integral in the definition of gamma of n. Look at here. Limits of this integral are 0 to infinity. We have e raised to minus x kind of term and x raised to n minus 1 kind of term. This integral in gamma notation can be written as gamma of n, and this n can be obtained by adding 1 in the power of x. Similarly, one can write this integral in terms of gamma notation. For that, one has to find this n, and that can be done by adding 1 in the power of t. Here power of t is minus 2 by 3. So minus 2 by 3 plus 1 is 1 by 3. Already we have 1 by 3 outside, and value of this integral is gamma of 1 by 3. So 1 by 3 into gamma of 1 by 3 is the value of this given integral. I hope you understood this solution. Now let's go for next example. Here I have slightly changed the integrand. Here we are asked to evaluate integral of e raised to minus x square by 4 dx over the limit 0 to infinity. Once again, first of all, we label this given integral as I. Then we compare it with the integral in the definition of gamma to decide the required substitution. We see that Here in this integral, exponential term has power minus x, whereas in this integral, exponential term has power minus x square by 4. So to reduce this term into this, we have to substitute x square by 4 is equal to t. Then we write x out of this statement. We see x square is equal to 4t. Therefore, x is equal to 2t raised to half. Then one can easily write dx by differentiating both the sides. We see dx is equal to 2 into half t raised to minus half dt. This 2 and 2 will get cancelled. So dx is just t raised to minus half dt. Now let's find out limits for t if limits for x are 0 and infinity. For that, let's substitute x is equal to 0 in this statement. We see t is also 0. Similarly, when x is infinity, t will also become infinity. So there is no change in limits for this integral I. Now let's transform this integral I from variable x to variable t. Integral I will become integral from 0 to infinity. E raised to minus x square by 4 becomes e raised to minus t, and dx we have seen is equal to t raised to minus half dt. Now simply compare this integral with the integral in the gamma definition. We see that if this integral can be written as gamma of n by simply adding 1 in the power of x, this integral can also be written in terms of gamma notation by finding n. To do so, we have to add 1 in the power of t. So if I add 1 in the power of t, I will get half. So value of this integral is gamma of half. Let us see another example. Here we are asked to evaluate integration from 0 to infinity of e raised to minus x raised to 5 dx. I hope by this example you must have guessed what we should substitute here so that this integral can be evaluated using gamma functions. First we label this integral as I. Then we compare this integral with the integral in the gamma definition. Then we decide that we should substitute x raised to 5 is equal to t. Then x is equal to t raised to 1 by 5. Therefore, dx is equal to 1 by 5 into t raised to minus 4 by 5 dt. Now let us see change in limits. When x is equal to 0, t will also become 0. When x is equal to infinity, t will also become infinity. Now we are all set to transform this integral from variable x to variable t. So integral I will look like integral from 0 to infinity of e raised to minus t into dx value is 1 by 5 t raised to minus 4 by 5 dt. Let us take out this constant. So we have 1 by 5 integral from 0 to infinity of e raised to minus t into t raised to minus 4 by 5 dt. Now at this point we compare this integral with the integral in the gamma definition. We see that this integral now can be written in terms of gamma notation as gamma of 1 by 5. This 1 by 5 we obtained by adding 1 in the power of t. So final value for I is 1 by 5 into gamma of 1 by 5. I hope you understood this example. Next is a practice example for you. Try to solve this example on your own and write me in comment box whether you are able to solve this example or not. Its final answer is already given here. Let's go ahead for next example. Here we are asked to evaluate integral of root x into e raised to minus x square dx over the limit 0 to infinity. As usual, we have to first label the given integral as I. Then we compare it with the integral in the gamma definition. So we see in this integral exponential term has power minus x, whereas in this integral exponential term has minus x square power. So we substitute x square is equal to t to reduce this integral into this one in this way. So we put x square is equal to t. So we see x is equal to t raised to half. Therefore, dx is equal to half t raised to minus half dt. Let us see what will be the limits for t when x square is equal to t is the substitution. For that, I put x value 0 here. So we see t is also equal to 0. Similarly, when we put x is equal to infinity in this statement, t will also become infinity. Now let us transform this integral from variable x to variable t. So integral I will be equal to integral from 0 to infinity with root x becomes t raised to half raised to half. Root x means x raised to half, but x is t raised to half. So x raised to half can be written as t raised to half raised to half. That's t raised to 1 by 4. E raised to minus x square becomes e raised to minus t. And dx can be written as half t raised to minus half dt. Let us take out this constant term and multiply these two t terms. So we have half into integral of t raised to 1 by 4 minus half into e raised to minus t dt. That's t raised to minus 1 by 4 into e raised to minus t dt. Now let's compare this integral with the integral in the gamma definition. We see this integral can be written in gamma notation as gamma of 3 by 4. This 3 by 4 we obtained by adding 1 in the power of t. So value of this integral I is half into gamma of 3 by 4. Let us go ahead for next example. Here we are asked to evaluate integral of x square e raised to minus x raised to 4 dx over the limit 0 to infinity. First we label the given integral as I. Then we compare it with the integral in the gamma definition. We see here required substitution is x raised to 4 is equal to t. Therefore, x is equal to t raised to 1 by 4 and dx is equal to 1 by 4 t raised to minus 3 by 4 dt. Now let's check limits for t. When we put x is equal to 0, t will also become 0. Similarly, when x is infinity, t is also infinity. Now let's transform this I from variable x to variable t. We see I becomes integral of x square can be written as t raised to 1 by 4 whole square into e raised to minus x raised to 4 can be written as e raised to minus t, and dx is 1 by 4 t raised to minus 3 by 4 dt. Let us take out this constant. Then after multiplying these two t terms, we see we have 1 by 4 integral of e raised to minus t into t raised to minus 1 by 4 dt. But this integral is nothing but gamma of 3 by 4. This 3 by 4 we obtained by adding 1 in the power of t. So value of I is 1 by 4 into gamma of 3 by 4. I hope you understood this answer. Let's go ahead for next example. Here we are asked to evaluate product of these two integrals. To do so, we assume I1 as this first integral and I2 as the second integral. We will solve these two integrals separately and then we will multiply their answers to get the value of this huge integral. So now we first compare this integral with the integral in the gamma definition. We see that for both the integrals, substitution is x raised to 4 is equal to t, which leads to x is equal to t raised to 1 by 4 and dx is this. We see that limits for t will not change. They will be remain same as the limits of x. Now let's solve integral 1. After transforming integral 1 by substitution x raised to 4 is equal to t, we see I1 is equal to integration of x square, that is t raised to 1 by 4 whole square, into e raised to minus x raised to 4, that's e raised to minus t, into dx, which is 1 by 4 t raised to minus 3 by 4 dt. After taking out the constant term and multiplying the t terms, we see it is equal to 1 by 4 integral of e raised to minus t into t raised to minus 1 by 4 dt, which is same as 1 by 4 gamma of 3 by 4. Now we solve integral I2. After transformation, integral I2 becomes integral of e raised to minus t into 1 by 4 t raised to minus 3 by 4 dt over the limit 0 to infinity. After taking out this constant, inside the integral we have e raised to minus t into t raised to minus 3 by 4 dt. But this integral is nothing but gamma of 1 by 4. So value of I2 is 1 by 4 into gamma of 1 by 4. Now finally, we take the product of values of I1 and I2 to get value of this expression. So value of this expression is 1 by 4 into gamma of 3 by 4 into 1 by 4 into gamma 1 by 4. So this is the value of the given expression. I hope you understood all these 6 examples that I have taught you. In my next lecture, we will see more examples that can be solved using gamma function. Till then, thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.